Hello. So I'm going to do two more examples of a solution to a system where the 2 by 2 matrix A has repeated eigenvalues, and these both have eigenvalues non-zero. All right. So this first example has the matrix minus 1.5 along the diagonals and 1 off there. And because of that 0 there, when you find the characteristic equation, it factors right away. And you'll find that lambda 1 equals lambda 2 is negative 1.5. And this one here has lambda 1 equals lambda 2 is 2. And again, the eigenvalues in both of these cases are just the diagonal entries because of the 0 here in the bottom left. Okay, here it has 0 in both places. Okay, so in both cases, we're in this situation, we need to compute the v vector. So here, v naught is a minus lambda 1 I times x naught, which, if I subtract minus 1.5 from the diagonals, it's like adding 1.5, and in this matrix is 0, 1, 0, 0, times 2, 3, x naught is 2, 3, and I do the multiplications, 0 times 2 plus 1 times 3, 3, 0 times 2. So there's v naught. Over here, v naught is going to be a minus 2i, we'll call it. Lambda 1 is 2 times x naught. Here, a minus 2i is 0, the 0 matrix. So here, the velocity vector v in this case is 0 for any x naught. So now we're ready to write down the solutions. In this case, we have the solution is x is equal to x naught, 2, 3, plus v naught, 3, 0, t. That whole thing gets multiplied by e to the minus 1.5 t. Okay, this is a lot like problem 7. And they want you to enter that x1 is 2 plus 3t all times e to the minus 1.5t. And then x2 would be 3 plus 0, e to the minus 1.5t. Okay. And over here, we're going to get the solution to this initial value problem is going to be x is 2, 3 plus 0, 0t, right? E to the 2t. That's just 2, 3, e to the 2t. And in fact, for x naught, for any x naught, this one is just going to be x naught, e to the 2t. So in the matrix is like this, in this case, 2 times the identity matrix. The initial x of 0, just gets multiplied by e to the 2t. And if this was negative 7, I just take x naught, multiply it by e to the minus 7t, and I get everything approaching the origin.